Bom dia, bom dia. Sejam todos bem-vindos. Vamos aguardar uns minutinhos aí, pessoal, entrar. Temos um convidado muito especial aqui hoje, o Amir, nosso parceiro de Israel. Vai fazer uma apresentação bem bacana para vocês hoje sobre BaseShift. Então, sejam bem-vindos, vão se acomodando aí, e em poucos minutos começaremos. Vamos dar mais um minutinho e eu vou chamar o Amir, tá bom? Mas, pessoal, adiantando um pouco sobre o conteúdo de hoje, o propósito da nossa reunião aqui hoje, do nosso webinar, para apresentar para vocês mais sobre BaseShift. Tá? BaseShift é um parceiro nosso estratégico de Israel, que está aprimorando sua atuação aqui no Brasil. Estamos expandindo o negócio aqui no Brasil. Temos clientes no Brasil, já tocando alguns projetos com BaseShift. Vocês vão ver que é um produto bem legal. Existe uma proposta de valor muito interessante por trás do que eles se entregam, do que eles se propõem a entregar, tá? Mas principalmente para poder compartilhar com vocês, né, o conceito principal do BaseShift. Então, ele é um produto que se propõe a criar clones de bancos de dados da versão de produção, mascarados e anonimizados para os ambientes de produção, de pré-produção, de desenvolvimento, para ambientes que agentes de IA vão utilizar para codar, para entregar código. Então, a ideia é que você tenha um ambiente seguro de uso de dados anonimizados e mascarados de produção em uma fase de homologação, de teste, de correção de bugs, sem risco para a produção e protegendo de custos, principalmente. Tá? Então, é um produto que gera esses clones, né, em segundos, é algo muito rápido. O Amir, ele hoje vai fazer uma introdução sobre o produto, uma apresentação global sobre o produto e depois uma demo. Tá? Ao final, vamos chamar para perguntas e respostas. Então, vão enviando suas perguntas aqui no chat. Bom, eu acho que era isso que eu queria compartilhar com vocês por hoje. A Sunny é uma empresa focada em observabilidade, FinOps. Então, percebam que aqui tem grandes produtos na nossa empresa que atendem esses cenários. Também atuamos na parte de Platform Engineering, AppSecOps. Então, vocês estão muito convidados a conhecer a nossa empresa, conhecer nossos produtos. Eu, como diretor comercial aqui, tenho a grande honra de compartilhar essas informações com vocês. Então, sempre que vocês tiverem dúvidas, nos procurem. A gente vai deixar aqui depois da apresentação o nosso site também. Mas hoje o foco todo, especialmente, é para BaseShift, tá? Então, vamos apresentar o produto. Eu vou trazer o Amir aqui para ele entregar para vocês esse valor sobre o projeto que eles criaram com o BaseShift, tá bom? Durante a apresentação, se vocês tiverem qualquer ponto, vão mandando as perguntas. Eu estou aqui para esclarecer também. A apresentação vai ser feita em inglês, porém preparamos os slides em português, tá? Para poder ajudar vocês a se guiarem na apresentação. E deixamos ao final também esse espaço para perguntas e respostas e nossos contatos para podermos evoluir com POCs, com reuniões mais focadas no produto, tá bom? Mais uma vez, sejam muito bem-vindos. É uma grande honra estar aqui. Contem com a gente e eu vou passar a bola para o Amir. So, Amir, floor is yours, man. Break a leg. Go for it. I believe Amir is going to come up in just a few seconds. We're waiting to shift gears here.
1, 2, 3, checking audio. 1, 2, 3. Sorry, folks, we're just trying to figure out the sound. Yes, good. All right. Hi, everyone. Welcome to the webinar. Okay, so we're on. Okay, so welcome to the webinar. I'm very excited to present this presentation about BaseShift, this time in Portuguese. I gave this talk in April at the Platform Days event organized by Sunny. It was very exciting. And we decided to do it again with a Portuguese presentation. So a little bit of background about BaseShift and about me. So I come from working as a DBA or as a consultant, helping companies grow their databases, watch after OLTP databases getting larger and larger and harder to manage. One of the things that happens when you are responsible for a database is it tends to be very scary. You begin to have a certain type of anxiety. I think in Portuguese, the word is ansiedade, because you know that you're in charge of a database, you know that developers and agents are pushing new code, and you don't necessarily have much control, you don't necessarily have much knowledge of what's being pushed to production, and that's kind of scary. Second, sometimes developers will come to you and say, hey, I have a bug, things aren't working, and it's not working in production. And so sometimes you're tasked with getting data from production and helping them fix problems. So this is what BaseShift is about. Typically, as DBAs, you will need to create copies. You'll have to create environments so that developers have access to the data they need. And as you know, this is not an easy task. So let's talk about this a bit. So as you know, there are solutions to this problem. People do shared environments. You'll have a system where you'll have some kind of staging, and you'll pull some data every once in a while, maybe every week, maybe every month. You might do a nightly dump. You'll have some script that you quickly wrote or your AI wrote, and it does a small dump, and you put some file in S3 or something, and then developers might download that. Or maybe you have a seed system where you're maintaining a whole bunch of scripts or some kind of database, and you're allowing developers to start up locally their database so that they can at least try out the app and see it load and play with the new feature. The thing is, a lot of these options have limits, especially today now that we're doing agentic coding. If you're doing shared environments, there's always conflicts. Developers will clash. They'll send messages in Slack, hey, who's using staging, who made a migration, who broke my staging. If it's nightly dumps, you'll have, if you're moving that fast, you'll have a stale database in the morning. You'll have different schemas. Relationships might start getting broken. And if you use seed data, well, the problem is that it doesn't represent production. So if you want developers or AI to write code that will pass production when it does a migration or when it runs a new feature, then it will have run on seed data. And that doesn't represent production. There's no edge cases, the amount of data is incorrect, and the app might generally act different on the seed data than how it acts in production. So the existing solutions have their limits, and we're running into them. So I assume that anyone watching this webinar is by now either using AI themselves or their developers are using AI. What this means is that whatever solution you had in the past to creating copies of databases or environments, that problem is getting worse, because when you have AI, every developer can now launch multiple agents or multiple tabs in Cursor or Codex or whatever tool you're using. And so the amount of environments you need is skyrocketing. So whatever was being done is no longer strong enough to withstand the demand. And so we believe at BaseShift that we need a new infrastructure to support the demand. So in addition to needing yet more copies, we need a few things. Let's take a step back. The database is beginning to be a bottleneck. Why is it a bottleneck? Because most likely, whoever's writing the code with AI, they're not really reading it. It's not practical. The amount of code being written is enormous. Second, even if they did, there's still a problem. You can't expect a developer to read this code that does a migration, code that might change a model, to know how does this change impact other pieces of the code or queries running in production that they aren't even aware of. The expectation that a developer or a team lead or a team technical lead will have the full knowledge of what's happening in production and be able to cross-reference all of that in their head is a bit much. So we need to make sure that we not only are not worried about what AI will do, but that we lean in and support AI. We want infrastructure that lets AI, let's say, be AI, right? It needs to be able to create experiments. It needs to fail rapidly. It needs to realize it made a mistake and be like, oops, okay, let me retry. I'll shut down my database. I'll start a new one. And you're going to want something that when a pull request is generated that touches the database will tell you what did the AI do to your database, or what change in the code did the AI do that might affect your database. And finally, not only do you want to know what has changed, you want to know how it impacts production if it rolls out. And we'll take a look at that in a moment. So we think that to meet these demands, you're going to need a rethink of how you're presenting data to the R&D and how your developers are enabling data environments for agents. First of all, you're going to want fresh data. You're going to want updated database copies from production that you receive every day, possibly multiple times a day. And you're going to want to feel free to create as many of these environments or writable copies as you want without having to think about cost. Because if you start thinking about cost, you're going to start limiting your developers, you're going to start limiting your agents, and you probably don't want that. You want to be in a position where anytime a developer starts up an agent, they type the prompt, they have the request, the agent starts up its database copy, shuts it down, resets it freely, and the human can just know about it. They're in the loop, but they're not actually in the loop of writing code. They're just notified and they have an idea of what's going on. Finally, if you decide that you want to bring data from production to AI, you do have compliance requirements. And I know that in Brazil, there are some very strict data requirements and compliance related to what data from production you can actually take out and present to developers and other R&D staff. Finally, you probably want something that goes as fast as the agent. I assume that you don't want something where the agent prompts the human and says, "Hi, human, I need a database," and then the developer says, "Okay, give me 5 minutes. Let me ping Jose on Slack and ask him, can you please launch another RDS instance?" And when he's done, you'll connect to the agent. You're going to want something that's not just automated, but fast. You want something that goes as fast as the agent. The agent wants a copy. It just sends a command via some interface. It can be CLI, it can be MCP, but it can freely launch up without having to wait. So we have a number of dimensions where we need to step up our game from what we were doing previously. We want to give fresh data. We want to give scale, so we can have many, many copies. We want to meet compliance, also meeting day 2 changes. The schema changes over time. You want to make sure that the compliance is met. And you want all this to happen very fast. And so that's what BaseShift is about. But before I dive in, let's take a step back and talk about why it's so hard. For those of you who have tried solving this, you know that it's never just a copy. It's never easy. There are many problems that you have to solve when you want to address this problem. First of all, you have the problem of scale. Like I said, if you have hundreds of developers, 200, 400, 1,000 developers, and you want to allow those developers to have preview databases, database copies, database branches, whatever you want to call it, you have to solve it in the multiples. So if you have 200 developers, you might need 1,000 copies. If you have 50, you might need 250, which is a problem. The second problem that I want to focus on is distribution. As I'm sure many of you have experienced, typically, you can't let developers connect to production. This is something that's both a problem of compliance, it's a problem of security, it's sometimes even a problem of accounting. The challenge here is if the developer can't connect to production easily, or if you don't want to start up R&D copies in production, what do you do? So what we've seen companies do is go the opposite way, meaning you want to take data out of production and you want to copy it into R&D. So you're going to have to actually move the mountain of data, and that's a challenge. You also want to do this very fast. So if I tell you a 2 terabyte database in production takes 8, 9, 10 hours to copy, and then another 5 hours to anonymize, then that's a problem, because you're going much faster than that. You're going to want to be able to press a button and quickly get a compliant copy of production. And of course, there's compliance. There are the regulations in Brazil. You need to always be on top of things. You need to make sure that all of the data that's sensitive really gets anonymized. You need to make sure that as schemas change and developers add columns, as they add stuff to JSONs that are opaque, you're going to want to know that you're safe and still compliant. So there's a lot of problems when you're trying to solve this problem. And for this reason, we built BaseShift. So what is BaseShift? BaseShift is an end-to-end, all batteries included solution to this problem. We connect to production. We take a look at the schema and some data. We recommend a masking policy. We facilitate the actual copying of data out of production while applying some policy of subsetting and masking. We wrap up the data as snapshots, and we'll explain what BaseShift snapshots are in a second. And we give you a method of distributing and connecting your internal customers to these snapshots so that each one can self-serve and launch as many writable copies as they need. So let's take a look at how that works. So in BaseShift, we give you software that you install in your cloud. This is on-prem, it runs in your cloud. We don't see your data. We don't want your data. It stays in your network. And we give you two components. One component is a server, which runs what we'll call the master replica. Another component is a connector or proxy. And so here's how it works. When you install BaseShift, you connect us to the source database, usually a production database of some kind, and we make a dump. We do like a backup as you would do a dump, like PG dump, MySQL dump, etc. But here's where BaseShift is a bit different from most solutions. Instead of taking the dump, copying it, restoring it, and then starting to run updates and various scripts, we take the data as it comes out of production and pass it through our proxy connector. That's the component labeled scrub PII. Because as the data comes through the connector, we open up the packets and modify them in real time. What that means is, by the time we restore the dump into our master replica on our server, which runs in your cloud, it's already anonymized. Now, the nice thing about this is it doesn't stop at copy. What you would probably want to do is say, after I make my first, let's say, 1 terabyte copy, I don't want to make another 1 terabyte copy. I'd rather get the deltas. And that's what our architecture allows. So after we make the first copy, we then use the built-in mechanisms to get deltas. So for Postgres, you would use logical replication. For MySQL, you would use standard binlog, and so on for Mongo and for the other databases. And the deltas themselves, the CDC transactions, pass through the same proxy and get anonymized just the same. The result of this is that you have a server in your cloud that has basically something like a read replica, but it's already anonymized when it was built and as it gets updated. And this is critical because when we create snapshots, you'll see how we use deltas to quickly give you new copies without having to wait much. So what do we do with this master replica? We create snapshots using BaseShift technology. BaseShift snapshots are not your typical snapshot. If you're familiar with Amazon, we don't use EBS or EFS. We don't use RDS. We don't use any of the storage services provided by any cloud. Instead, it's quite simple. Our snapshots are just files. Think of a folder with a whole bunch of binary files. You can do with these snapshots what you would do with any files. You can put them in S3. You can put them on a USB drive. You can send them via SFTP. I think you get the point. The point is, about that, you can then take the snapshot and put it in a Docker image, or as I said, in S3, and transfer it to wherever it is you want to run your database instances. So if production is maybe in US East, because you're a Brazilian company, but your customers are in the US, and you want to run your R&D copies in Brazil, then you can do that. You create a snapshot in US East, you take those files, or you take Docker images that contain the files, and you just pull them or copy them back to Brazil. Or you can do the same between different accounts in the same region. Perhaps you have a production account where you don't allow developers to connect, and to pull data out, you generate Docker images, and developers can pull them, or you pull them into Kubernetes running in a separate account. Also, if these snapshots are too big, maybe you have a 10 terabyte database and it's not practical to copy 3 terabytes or 5 terabytes, then the server itself can start up many, many clones. And by clone, I mean a writable copy. You send us a command via a variety of methods. It can be a REST API, it can be CLI, it can be via our dashboard. And the server itself will spin up a writable clone. We'll see this in a few moments in a demo. So let's visualize the process. Let's say you have a 1 terabyte database in, just for the sake of discussion, RDS, and it's a Postgres. And let's say you want to transfer it to some Kubernetes running in a different account. On the first day, you take that whole terabyte and you create a snapshot. Now, BaseShift snapshots are also compressed, and they stay compressed while in use. So that snapshot will be, say, a 300 gigabyte folder or a Docker image. You will pull that into your Kubernetes or other region, and you can start working. But let's say a day has passed, and you want a fresh snapshot. You probably don't want to copy that entire 300 gigabytes again. You would want the delta. And as we mentioned, there is a delta mechanism. We do get changes to database rows. So we double down and we say, okay, if let's say 10 gigabytes of data in the database has changed from one day to the next, we can create a BaseShift delta snapshot out of that change. And if you've already copied 300 gigabytes, you can now copy a delta snapshot, which is again just files, with you. So you just make that delta snapshot and you just ask for those files and they copy along. And that allows you to create a clone over the delta snapshot. The clone is a fully writable Postgres, MySQL, Mongo, SQL Server, whatever database you're running. The clones are lightweight. They don't need to copy all of the snapshot data when they start up, and they don't see each other. So when you start up on a server multiple clones, you can start up dozens, even hundreds. They don't see each other, but they share the snapshot data, which is a very big cost saver. Similarly, if you're using Docker or using the files, one Docker image with 300 gigabytes of files can serve many containers that start up on that image without duplicating the 300 gigabytes. That's very convenient because it lets you do things you couldn't do before. So this is the difference that BaseShift enables. Let's take a look at some of the key benefits. What does BaseShift allow us to do? So first, the installation is relatively fast and easy. We have a wizard. It helps you set up. We will soon even have an MCP that'll help you set up via AI if you really want to. But typically setup for a decent-sized database is somewhere between 10 and 15 minutes, sometimes 20 minutes, depending on your environment. You can set us up in Kubernetes. You can set us up in Amazon or any other major cloud out there. Of course, copying data takes time, so perhaps it'll be a little longer than 30 minutes. But the effort from your side is very low. There's a security-first architecture, meaning, as I said, the data never leaves your network. You control it. It's all on your network. And we allow you to do multiple types of clones. So you can do a server clone or a Docker clone or both. I'll give you an example. Let's say you have a production database and it's pretty big, maybe 1 terabyte, and there's a small fraction of that you want to give developers, maybe 10 gigabytes. They don't need more than 1% to do their job. So you create one, let's call it output. That output creates the 10 gigabyte Docker images that they can download locally. But you also want something that lets the CI/CD automatically run tests on the full database. And so that's what remote clones can let you do. The remote clones, as I said, they run on the server. They let you start up many copies at the same time, which is very convenient for CI/CD. And they are fully managed centrally. So you can say, let's turn them off after a certain amount of timeout. Let's monitor how they're being used, etc. Next, A, because of our compression, and B, because of the way we run clones sharing the same snapshot, typically our customers see 70 and sometimes even 90% reduction in costs. One of the nice things about this is that not only does it possibly reduce cost in your current workload, it unlocks things you've prevented yourself from doing because of cost. So maybe you had a thought, I'd like to create copies of production for every pull request, but that'll take too long, or that's too expensive, or it's just not practical. Now, that is possible. Or maybe now you're beginning to bring in agents and your developers are launching multiple coding efforts or coding agents running simultaneously. And they're complaining and saying, I really like a copy per agent. And you're with your hands in the air because you're not going to create an RDS per agent. That's too expensive and too slow. And you're not going to create big Docker images that are transferred to every agent every time they spin up. That's expensive and slow. So you're going to want something that reduces the cost of this infrastructure so low that it enables things you just couldn't have done before. Now, finally, our technology is relatively database agnostic. And the meaning of that is we don't really tie ourselves to a specific type of database. So we're not a solution for Postgres. We're not a solution for MySQL. We're a solution for databases. And this is important because most likely you don't have one database. This is 2026. You probably have a Postgres and a Mongo and a Redis. You probably have a MySQL and a ClickHouse. You have many databases that together comprise what you might call a data environment, a combination of databases where together they allow the app to start up and execute. If you have a copy of just one of them, then maybe only a fraction of the app will work, which creates a headache for the developer or the agent. So we understand this first class. We have a concept called a data environment. You can take multiple databases and connect them together and call them, say, a production environment, such that when you snapshot them, they snapshot together as one unit. And when you want a writable clone, you launch multiple databases at the same time. What you would ideally like is for an agent to decide it wants an environment, it sends a command, and it gets back a set of connection strings. It just gets its a list of ports, and it says, here's Postgres on port 5432, here's MySQL on 3306, here's your Redis, here's your Mongo, and away you go, and you're good. This lets you as an infrastructure engineer, as a platform engineer, think at the higher level. You don't need to deal with creating a whole infrastructure for Postgres and a whole infrastructure for Mongo. From your point of view, it's one unit that moves together. And that makes life pretty easy. So how does this work? What does it like visualized? You have a developer, or maybe even product, create a prompt, which starts up a coding agent. Now we're already in August 2026. Maybe some of you already have a cloud agent running not even on the developer's computer. So an agent spins up, and it has its own little sandbox where it starts starting up the code, setting up its development environment. But also, that agent can autonomously decide it needs a copy of the database or data environment. And so it issues a command to BaseShift. BaseShift spins up an isolated, anonymized, very fresh copy of the database, where only that agent has access to that database. And the infrastructure doesn't really care what the agent does to that copy. It can mess it all up. It can drop tables. It can do whatever it wants. And if it decides that it made a mistake, it can just send a command to BaseShift and say, oops, I messed up, undo or reset, let me try again. And that's exactly what will happen. It'll send a command, it'll shut down, it'll start a new one. No one's the wiser. Once it decides it's done, what you'll see is that BaseShift captures the changes. We understand what did the agent do to the database, and then you can destroy the environment. So what is the outcome of this? At the end, the developer can ask the agent to reflect off of BaseShift and say, I made this change. How will this affect the database? And is there any risk? Is this a problem to roll out? And basically, can I take the pull request and merge to production? So that's the full pipeline. Let's do a short demo. So I will try to share my screen here in a moment. Wrong screen. Sorry about that. Okay. So this is cursor. We have here. Just a moment. Oh, it's still the wrong window. I apologize. Okay, found it. So, a quick explanation of what you're going to see. What we have is we have an app which we built in Django. It's a Python app, and we built it intentionally to showcase what BaseShift can do. It's a pretty simple app. You can find it on GitHub. It just has a handful of tables, and we're going to ask AI to run a migration. The migration has a very simple task. I'll explain what it's doing while it runs, and while it runs, I'll show you some of what BaseShift sees on our end, and at the end, we'll take a look at the outcome, and you'll see how cursor decides to start up a copy, tries to iterate, makes a mistake, fixes the mistake, stops the database, starts a new one, figures out that everything's okay, and then says, okay, I'm done, I got it. So we're going to start this effort, and in the meantime, I will show you BaseShift. Let's switch. All right. So this is BaseShift. This is our dashboard. The first thing you see is what we call a list of dubs. A dub is a database source plus some policy. It can be masking policy, it can be a subset policy, it can be both, and some snapshot schedule. So what's the idea here? You can say, I have this RDS Postgres database. I want to create a copy every day of just 1% of the data for developers. So that would be, let's call it the developer dub. You might have another dub that's meant only for CI/CD, and no one has access to it. But it does contain all of the data, and the changes are recorded as is, and the snapshot is created maybe every hour. So that's what this screen shows. I've gone ahead and created a dub, so you can see what it looks like. This is a test dub. It controls a server that would be running in your cloud. And you can do a few things with it once it's set up. The first thing you can do is you can get the Docker image. So you press this button, and you have a set of commands. You just copy paste into the CLI, and you have a Docker image you can run. I'll add that Docker images have encryption, and you need a special password in order to open them. We don't have this password. That password is stored with you. So even if somehow someone got a copy of your Docker image without the encryption password, they can't open it. Second, if you want to launch a server clone, the first way you can do it is by clicking Launch Clone. And that's it. A new database is up. Anyone can connect to it if they have the password and the port. It isn't shared with anyone, but if you decide to, you can share it with others. And you can just press this copy as PSQL and connect immediately. And I'll show you how that works via the CLI in a moment. You can also set up your policy. Let's take a look at how that works. We get the schema from the database, and we allow you to set up specific rules. We'll find sensitive columns like names and emails, and we'll set up a masking function. You can configure this in a number of ways. You don't have to go one by one. We have an automated PII scanner. So when you install BaseShift, we will connect to your source DB, as I mentioned, scan all the tables, scan all the columns, and sample some of the data. And we will look at what we think is a good masking policy, which allows you to get started quickly and then modify it to your needs. So that's how the scanning works. You also can configure subsetting. And the idea here is if you have multi-tenancy, so you have maybe a table with tenant ID or customer ID or company ID, and you want a certain subset of the database based on that company's ID, we let you configure a template. And you can say every table with the customer ID column can be of value 1, 2, or 3, but not the others. You can also add custom predicates. You can also tell us to use JSON, or you can even, and this is coming soon, you can tell us, okay, start from the tenant table, my list of tenants. I want tenant 5, follow all the PKFKs and get me only that tenant's data. Of course, we allow you to give us regexes to remove tables and to include tables. It's pretty flexible and lets you configure it as a rule and not just going table by table. So I will also say that everything you see that I'm doing through the UI, you can do through API. And the idea is you can fully automate the control of BaseShift. You don't have to log in to make all these changes. And you have the ability to separate admin users from regular developers. So the admin sets this all up. They have control over the masking policy, and your developers or agents on their behalf can only launch clones and shut them down. So while I was showing you this, the demo was running, and we'll get back to that in a second. I want to show you what it was doing and what's interesting about it. So I'm going to come back in a second, and I'll explain. This is a database called the Acme HR database. It's used for training. It has a whole bunch of tables, and these tables are reflected in the code that I told you about. Now, the prompt is asking the AI to take a column from one of the tables, let's say title, and normalize it. Now, this is a standard task where you say, I have a string column. I want to create a new version of the app where all the different values are in another table. So it's a common request. So the AI is going to try to attempt this change, and it's going to hit a wall. It's going to make a mistake. And there's a certain problem that's going to cause a constraint to be violated. And let's see, what does the AI do? The point being, this is a typical thing that happens to agents. They try to run some change, and it passes on example data, and in production, it would fall. But since we're bringing production data to the developer or to the agent, at least it'll notice that it messed up or that it would mess up, and it makes the fix while in development. So let's take a look at that. That would be this. Oh, it was waiting for approval. All right, it'll start running. What's going on here? So the AI inspected the model, realized what it needs to do. It did realize, I think it did manage to start up a copy. You can see that it ran a query. And let's see if we can find it. It created a clone. And it will try a migration. What's going to happen is it's going to hit that wall, and it's going to attempt a migration, and it will realize it failed, and then it's going to restart. We'll just wait a couple of seconds. And so an important thing to notice here is all of this happens without the developer's input. By chance, I had to give it an approval, but when it's running as an agent, it just runs automatically. So now it's running the migration. It's running an attempt. and it failed. And this is what happens. The exact error that I was mentioning occurred. It tried to make a change. It was unaware of some duplication in the data. This duplication came up only because it attempted the migration on a real copy of production. So now it realizes its mistake. It's going to rewrite the migration, and it's going to retry on a fresh clone. And that's what just happened. It had a clone. It tried to run the migration. It realized it didn't work. It's stopping the clone, and now it's going to start a new one and rerun the migration, and I think this time it'll succeed. Yep, this time it succeeded. So you might imagine, if you want to roll out AI agents, you're going to want this process to happen automatically. And the only way to do that is to provide infrastructure that you can just plug into the agent, and it can start up the clones and shut them down all by itself. Now, remember how we talked in the beginning about how do I know what the AI did? How does that affect my database? So I want to show you what we see in BaseShift. Here's a list of clones, and here are the clones that I started up myself just a minute ago. One of these clones is the clone that the AI ran. And we can see, I'm pretty sure it's this. We can see that all the queries are recorded. And we can see, for example, that the AI wants to make a modification where it's modifying an important table in the system. Now, why is this important? You're going to, first of all, want to reflect this back to the agent. The agent writes the migration in, say, Python or Java or PHP or whichever language you're using, but it doesn't necessarily know how this change affects the database. So first, we can say here, just so you know, you're running an update on a production table. But more importantly, you want to know if this is dangerous. And that's where BaseShift comes in. BaseShift's endpoint is a pull request. Right? So think of the process we went through. The AI got a task. It created a clone. It tried to make a migration. The migration failed. It realized it made a mistake. It shut it down. It created a new one. It made a new change. And now it's submitting a pull request and saying, please accept this change. As a developer, you're going to say, okay, what did this change do to the database? And what BaseShift shows you is we created a new table. It created a new column or modified a column in an existing table. But more importantly, there is a risk in this change. If you make this change, someone's query, maybe Roberto is running queries on the side on the database. It's a known query. It runs every night. And if you make this change, this query is not going to run. That's important to know, because maybe you'll think to yourself, well, if I'm going to make this this rollout happen, I have to do it on the weekend, or I have to do it after talking to Roberto. And second, part of the migration itself will take a lock. That lock might prevent the app from running smoothly. And that's another thing that you have to keep in mind. You want some idea of how is this app going to affect my production workload, despite me not knowing what's going on in production. And if you have, if you know that this information is available to you, if you know there's a system that is taking a look at the changes, that is taking a look at how is the AI affecting your database, it should give you more confidence to let the AI loose, because you're saying, all right, I'll know if something's going to happen. There's a system looking out for me. And that is what BaseShift provides. So with that, the presentation is over. We thank you for being on the webinar. You feel free to reach out to us to leave a note on our forum, or reach out to Sunny, and we're happy to meet you and give you a personal demo and discuss how BaseShift can help you use agents confidently. Thank you very much.
That was amazing, Amir.
If
Thank
anyone
you.
has any
Thank you
questions,
so
we have a
much.
few minutes left. I'm happy to answer them.
Well, I'm going to share some of the questions that we got from the chat. Can you hear me? I don't know if you can hear me, but I'll send you the questions here at the chat, so maybe you can hear me. So I sent you the first question. I want honestly for you to share what was the aha moment that made you realize you had to build BaseShift.
Roberto will translate to Portuguese. I'm sorry, I don't read Portuguese. Yeah, sorry, there's a very short time delay.
So Amir, first question in the chat. I just sent you there.
I built BaseShift honestly because I was a DBA and because I had to be responsible for databases, and I realized this is a growing problem. We, as DBAs, we are responsible. We have a certain anxiety.
Nice, great point. Yeah, I recall you mentioning the anxiety at the beginning of the presentation. Thank you for that.
There's a bit of
also, I wanted to share with you another question coming from the chat. You mentioned that you are agnostic, right, to databases
itself,
but which databases are compatible with?
That for a very big database, there's a constraint, and the constraint is you typically can't do 3 things at once. Okay. Okay, I'm sorry, guys. There's just a very long delay. So things here are a bit with a 15, 20-second delay. So I'll move on to the next question. I realize that you asked if it's agnostic.
Yeah, I'm trying to sync here with Amir. We're having a bit of a delay in the communication.
MySQL,
Sorry
Marina,
for that, guys.
Mongo, DocumentDB, and we have a POC for SQL Server. We can support SQL Server if you want. More recent versions rather than the older versions. But we're also on the roadmap adding a few more. I think ClickHouse is on the roadmap. I think OpenSearch or Elasticsearch are on the roadmap. We're willing to work with you if you have a specific need. Okay, I see the next question.
Thank you, Amir. I keep posting the questions in the chat.
When each developer or AI agent gets their own database clone, how do you control costs and prevent the uncontrolled proliferation of these environments? That's a really good question. First, as I said, there's 2 ways to get clones. You can get a clone either by spinning up a Docker container, in which case the control is on your side. You decide when a container is open or shut down because it's your infrastructure. When it's a server clone, it is fully managed by you. So there's a whole range of solutions here. You can have, first of all, auto shutdown. So as soon as a clone has not been in use for more than a few minutes, it automatically shuts down. You can set up permissions. You can say certain developers don't have access. We can add even more. We can say, all right, there's some credits. There's some mechanism that allows or prevents you to create a clone. Importantly, you don't have to give the developers the API itself. It should be pretty easy to take the API or the CLI and wrap it yourself. And so you decide when the clones start up or shut down. If there's a specific need, if you have some specific mechanism in mind, we're happy to meet and discuss your needs and see if this is something that we can do for you or we can do together, or perhaps Sunny can help you develop such a solution that connects to our API and closes that gap for you. So I'll move on to the next question. How do clones enter the pipeline? Is it possible to automatically create a clone for each pull request and discard after testing? That's also a very good question. And the answer is yes. I'll answer the second question. We have customers doing this right now. Customers have it set up so that every time a test run begins, it'll call out to the BaseShift CLI, we'll start up a clone. It takes just a few seconds. And when the pull request ends, it just shuts us down, or we auto shut down. And we can do this at scale. We can do dozens, hundreds of simultaneous clones, so you don't have to worry. And how do clones enter the pipeline? I'm afraid I don't fully understand. The clones are controlled by you. You have an API or a CLI, or like I said, maybe you work with Sunny on building some system that controls how clones are started, and that system controls our API. This lets you control how the clones are started up. Or perhaps I didn't understand the question, so please clarify. The next question is, what is the most unexpected imagined? Well, for me, the most unexpected thing is we have a client who doesn't primarily use us for development. The primary use case is sales. This surprised me because as a DBA, I haven't seen this before. What happens is this is a customer who needs to provide the sales team writable demo environments. The idea being, let's say you have a salesman and the salesman wants to show a potential customer your product. And the salesman says, listen, the customer said, I like it, but let me play with it. I want my own little copy of the system on the side. You'd probably, if you're doing this at scale, you don't want to do this on production because production will be full of garbage. So your R&D team says, okay, so let's create Kubernetes temporary environments of the app where the prospect can play with it for a month and then we'll shut everything down. So we approached this customer and much to our surprise, the main question, the main use case was this. The customer has dozens, by now hundreds, of environments run by dozens of their salesmen. The salesmen provide these environments to the prospects, and they do this for a very cheap price. Rather than adding stuff to production, rather than creating database, whole RDS clones, they create a small Docker image that is maybe 1/100th of the full database. It's self-contained. They can start up a Kubernetes environment, and every salesperson can start up as many of these environments as they want. We know that this has been very lucrative to this customer. It was quite surprising. They rely on this daily, and they have hundreds of copies of databases using BaseShift. So that is the most surprising thing that I've seen a client do with BaseShift.
Amazing, Amir. Thank you so much. That was really good. Really like the way you position it. Let's wrap it up. I'm going to switch to Portuguese, but thank you once again.
Let me know if there's
we'll be in touch. Pessoal, para finalizar aqui, muito obrigado pela participação, muito obrigado pela presença, pela audiência. Foi uma audiência incrível, gostei das participações com as perguntas também. Então, só para finalizar aqui, amarrando, tá? Então, o foco do BaseShift como solução é auxiliar na velocidade e na segurança, tá? Nesse mesmo movimento em conjunto. Entre em contato conosco, vamos fazer uma POC, deixa eu apresentar o produto para vocês. Eu tenho certeza que ele vai mudar toda a experiência de vocês com o desenvolvimento e a parte de banco de dados com segurança, que é o principal. tá? A gente vai mandar algumas mensagens para vocês depois, uma landing page para vocês baixarem o material e deixei os nossos contatos aí no chat também, tá bom? Muito obrigado a todos, tenham um ótimo dia, um ótimo final de semana e contem conosco. Contem com a Sunny como um braço local para apoiar vocês com o BaseShift. Até a próxima.